Hello physical science students, welcome to a new topic. In this case it's called carbon chemistry, sometimes also referred to as organic chemistry. Carbon chemistry because we were looking at all the molecules that are based around carbon chains, and that comes from the fact that carbon likes to have 4 bonds, which we learnt earlier, and in terms of covalent molecular stuff, carbon can form carbon-carbon bonds, and those carbon-carbon bonds can form long chains. And so there's a whole branch of chemistry referred to as carbon chemistry, sometimes referred to as organic chemistry, because it's about all the molecules that make up you, me, plants, animals. Pretty much we're based around carbon chemistry, and that's why it's also called organic chemistry. So let's get into it. So far in chemistry, we've been looking at what's called the branch of chemistry called inorganic chemistry. This stuff here. So we did ionic compounds, molecular compounds, giant covalent lattices, and we haven't done this, guys, but we've done these other ones. And they're organic molecules. They're not related to living things, or they're not the basis of living things. We still use them as we are living things, but they're not what defines life. And that's quite a huge area of chemistry. But the other area of chemistry is called organic chemistry, and what we're going to be looking at is the hydrocarbons. We're not going to look at alcohols, lipids, hydrocarbons, or proteins. You'd have to do year 12 chemistry just to touch on those. So we're only going to look at a little bit of what's called organic chemistry, and it's a huge area of chemistry as well. And so we're just going to do the tip of the iceberg. But we're moving over into this area, the organic chemistry area. So what we're talking about here are molecules that are based around carbon-carbon bonds. And so here the black represents carbon-carbon bonds. And so we've got 1, 2, 3, 4, 5 carbons joined together in a chain, and then we've got hydrogens coming off them, and that's referred to as pentane. Here we have a typical fat molecule, so you can see these carbon chains, but you also got these red represents hydroxide extensions. And then you have ethanol, which is a very simple molecule, which is one of the alcohols. So we can go very big molecules, and this is not a big molecule in terms of organic molecules. When we do hydrocarbons in a short while, you'll learn that some molecules have hundreds of carbons in them all joined together. But that's a typical fat molecule. And notice the funny shape that they have. The shape of molecules is a whole branch of chemistry as well, which is quite interesting. Things like proteins and enzymes, their chemistry is often dictated by their shape, and people spend many years studying different shapes and trying to formulate different chemical compounds to do certain things. So what do we mean by organic compounds? It's the study of compounds of carbon. A large number of compounds that carbon forms can be explained by its ability to form 4 bonds, which I mentioned. I forgot to mention that, again, we said earlier when we were doing covalent molecular, carbon can have single, double, or triple bonds between them, and so we can have that. And carbon can also form ring structures, or cyclic, so circles of carbon bonds. Now, hydrocarbons, what do we mean when we use the term hydrocarbons? Well, they're organic compounds made up of only carbon and hydrogen. For us, we're not going to put any other extensions on them apart from a couple which we mention later on. Then we divide hydrocarbons into 2 types of hydrocarbons. We have the saturated hydrocarbons. They only contain single bonds between the carbon atoms. Remember that? And so because they've got single bonds, they've also got the maximum number of hydrogens. And when we start drawing them, you'll see what I mean by that. And the other type of hydrocarbons are the opposite, which are unsaturated hydrocarbons, and they can contain double or triple bonds. And for us in physical science, that's only 1 double bond or 1 triple bond. We don't duplicate. So saturated, only single bonds between the carbons. Unsaturated has a double bond or a triple bond between the carbons. So there are different classes of these hydrocarbons based on the carbon bonding that occurs. Okay, so methane, this is a molecule of methane. This is the simplest hydrocarbon. So one carbon and 4 hydrogens, and this is how it's drawn in 2 dimensions. This is trying to represent its 3-dimensional shape, and each of these lines represents a covalent bond. So this carbon has its 4 bonds. Ethene, it has a double bond between 2 carbons, drawn like this. Okay, and ethine, it has a triple bond between the carbons. So these 2 would be unsaturated hydrocarbons. This guy would be saturated. And a way of thinking about saturated is, has it got the maximum possible number of hydrogens? This one could actually have 2 more hydrogens. So have 3 hydrogens off there, 3 hydrogens off there, and a single bond between there. And we'll look at that later. So these are unsaturated. There we go. I had that already. So the classes of hydrocarbons, we've got this diagram. We have all hydrocarbons there, and then we have what's called straight line and cyclic. We're going to learn about the circular ones. We are predominantly talking about straight line ones, but we will do a little bit of cyclic ones. Each of those classes are broken up into saturated and unsaturated. And then in the straight chain ones, we have the alkanes, alkenes, and alkynes. Whereas here we have the saturated and the unsaturated. And we're going to look at these 3 classes of hydrocarbons in a little bit more detail, but fairly quickly. And so in the next video, we're actually going to look at the first group of those, which is the alkanes. Cheerio!